everybody. Today we continue our discussion on stoichiometry. But today's calculation involves how many moles, how many mass, how many grams of mass, and how many particles. The first example, I have chlorine and sulfur. They react with each other and produce, this is called a disulfur dichloride. Now the question is, I want to produce 50 grams of disulfur dichloride. The question is, how much chlorine do I need? Now in this case, in this example, how many molecules of chlorine do I need in order to produce 50 grams of disulfur dichloride? So how many particles? X particles. In this case, the particle means molecule. Okay. I need to find the mass of this. Go to periodic table. Find the atomic mass of sulfur. Atomic mass of sulfur. But I have two atoms here, so I have 2 times sulfur, the atomic mass of sulfur, it's this. So this is the mass of S2, but I have Cl2. Cl, I have 2 here, so I have 2 here, 2 times. What is the atomic mass of Cl? So this is okay, my calculation is this. I have 2 sulfur, 2 times atomic mass of sulfur is this number. I have 2 chlorine, so I have 2 times the atomic mass of chlorine, I have this number. So for this together, I have this and this add together. So these two numbers, I have to add them together. Let's add them together. So you add, it is 135.04. So this is this number. That's a mass of disulfur dichloride. I put this number below the 50 gram because this is also gram. So I have How about this? I want the number of molecules of this thing. Look at the number before the chlorine. The number here is just 1. This 1 means it's 1 mole. Then 1 mole of chlorine contains how many molecules? It's Avogadro's number. So it is this Avogadro's number. This number is 1 mole of chlorine consists of this many molecules of chlorine. So this is molecule. So molecules. So you have molecules, molecules. Gram, gram. Okay. The units must be the same. Molecules, molecules. That's just a number. And here is gram and gram. Now once you have that, you divide, put equal sign here, and so I don't need the unit anymore. So this is what I have. X divided by that is equal to 50 divided by that. Therefore, I can find x very easily. Just use your calculator. Just use your calculator, find x. So my x is this is my result. This means I need this many molecules in order to produce 50 grams of disulfur dichloride. Okay, so this is molecules. So that's this example. Just use a ratio. Okay, the next example. Example 2. Aluminum, oxygen, they react with each other. This is just oxidized. Aluminum is oxidized to become aluminum oxide. So the question is, I have 0.4 mole of aluminum this will combine with oxygen completely chemical reaction. This many moles will combine with how many grams of oxygen? X grams of oxygen to produce aluminum oxide. In this question, the given is how many moles. The unknown is how many grams. Okay. Now from the reaction equation, I want more here. The reaction equation tells me if I have 4 moles here, then I need this many grams of oxygen. So what is the gram number for this? Oxygen is 16. Oxygen is 16 atomic mass. I have 2 here, I have 3 here, so altogether is 3 times 2 times 16. So this is atomic mass of oxygen is 16. So I have 2 here, I have 3 here, so I must multiply 3, multiply 2, multiply 16, I get 96. And then I put this number below the x. Let me erase this. And this is gram. Now, just like the first example, I write the ratio, make the 2 ratios equal to each other, and I solve for x. So do the ratio, erase unit in order to not confuse us. Make the 2 ratios equal. So you use your calculator and find x. Cross multiply x is this times that, divide by 4. This calculation is very easy because 0.4 divided by 4 is 1/10, and so 96 divided by 10 is 9.6. And x is gram. So my answer is, if I have 0.4 mole of aluminum, I can combine this, I can react with 9.6 gram of oxygen, and they form aluminum oxide. So this is very similar to the first example, except I have mole here, gram here. So remember, mole and mole, you must have the same units, and gram. Okay? And one more tip. You see, my calculation, I suggest the first line, you write down what is given in the question, and also what do you want to find. What is given? Put the given. What do you want to find? Then the next line is from the equation, from the reaction equation. This number is from the reaction equation, 4 here, 4. And this 96 is from here. That's the equation, that's the oxygen in the reaction equation. So line 1 is what is given, what do you want to find? Next line is from the reaction equation. Yeah. You do this systematically, and it's very easy. So once you have the numbers there and unknown here, do the ratio, let them equal to each other, find the unknown. The unknown is just using cross multiply. Use a calculator, find your answer in one step. So that's example number 2. Next example. Okay. Next example, calcium and chlorine react with each other to produce calcium chloride. Okay. What is given? Calcium is given 4.3 grams. What do I want to find? I want to find the product. How many molecules? How many molecules? X molecules. Given unknown. Now, this is line 1, okay? Given unknown. Then from the equation, because this is gram, I need a gram of calcium. The calcium is, atomic mass is 40.08. Okay. I want how many molecules? So how many molecules? Look at this number. 1. 1 means 1 mole. So 1 mole consists of how many molecules? How many particles? It doesn't matter whether it's molecule or atom. 1 mole consists of Avogadro's number particles. So Avogadro's number here. So this is a molecule, so we are talking about molecules. And this is 1 mole. 1 mole contains that many particles. In our case, the particle is molecule. So, just like before, okay, so this is gram from the formula, calcium, that's atomic mass in gram, and this is Avogadro's number. Okay. So I think you are very good at this now. Divide, erase the unit, let them equal, cross multiply, what is x? Move this number to there. Move this number to the numerator on the other side. I don't want this anymore. And this is my x. Use my calculator. You find the x right away in one step. So what is the x? X is so this is number of molecules. You see how simple that is? Okay. One more example. So this is sodium. Probably you will say sodium nitrite, but there is a special name for this. It's called sodium azide. When this decomposes, you produce nitrogen and sodium. Okay. Okay. So what is given? I given this thing decomposes and produces 80 grams of nitrogen. And how many atoms of sodium is produced? So this is number of atoms. Number of atoms I don't know. I want to find it. So why in this example I am talking about atoms, but in the example before this I'm talking about molecules? Well, because sodium is an atom. In this formula, Na is an atom, right? It's not a molecule, it's an atom. Actually, it is a molecule, but one molecule of sodium contains one atom. Okay, so I can write atom. So given unknown, because this is given in grams, so I need gram from this reaction. So what is the atomic mass of nitrogen? It's 14, right? So it's 14. This is 14, 14.01. And I have 2 here. So multiply 2. I have 3 here. So multiply 3. So this is equal to 84.01, and this is gram. You see from the periodic table, atomic mass times 6. Atomic mass times 6, I get this in gram. And how many atoms are here? I have 2 here now. This 2 means 2 mole. 1 mole contains Avogadro's number of particles. But I have 2 moles. So how many particles are there? It's 2 times the Avogadro's number. So it's 12. It should be 12.04 times 10 to the 23. So I put this number here. Okay. 2 times Avogadro's number here. And this is number of particles. In this case, your particle is atom. So erase this here. Erase the units. Ratio equal to each other. Cross multiply means I move this denominator to the numerator. So I I move this move this denominator to the numerator on the other side. So this is my x. So you use the calculator to find x. X is okay, you can write it. Use your calculator to do this, and x is this, and I can round it. So move the decimal here. This becomes 24. So that is my answer. So actually the calculation, it doesn't matter whether you're talking about moles, you're talking about grams, or you're talking about how many particles. Just write down on the first line what is given and what do you want to find. Put down the units. Then on the next line, from the equation, write down for gram, you need periodic table, find atomic mass, and do the gram for that particular compound in the equation, reaction equation. If it's mole, then you look at the coefficient before the formula. The coefficient before the formula means the mole. And if you talking about how many particles, then you look at the number before the formula again, because that's the number of moles, but you want particle, so the number of moles multiply the Avogadro's number. Once you have the second line from the reaction equation, and the first line is what is given and what do you want to find, write down the fraction, let the two fractions equal to each other, cross multiply. In my case, because I have unknown on the line 1, then you move the denominator under the unknown to the numerator on the other side. Use the calculator to do the calculation in one step. Yeah. Learn how to use the calculator in one step. And that's your answer. Finished. So this is not difficult if you know how to use your calculator efficiently, right? Okay. That's all for today. The next lesson will be about limiting reactant, or you can say limiting reagent. Something is not, the quantity of something is not enough. Then there is something you called limiting reactant. That's the topic of the next lesson. Goodbye. See you next time.